Welcome to today's deep dive. So I want you to think about, well, the absolute last stage inside your production plant. Your digital team is working at high speed, designing patterns flawlessly, but the hardware generating the physical output just crawls, right?
Yeah, exactly. I mean, it's the classic bottleneck. We obsess over software efficiency, but in the end, the ink actually has to hit the paper.
Right.
And if that physical step is slow, all that digital speed you built up is practically useless.
Which brings us to the mission of our analysis today. We are looking at how to solve this large-scale efficiency problem by examining the specs for a very specific piece of technology, the velocity vector 4 marker plotter.
Right, the velocity vector for marker plotter. When you read through the company's documentation,
Yep.
the entire architecture revolves around throughput. It's
It's
all about maximizing production capacity.
because the physical bottleneck is the primary enemy here. Right.
Exactly.
Right.
And the manufacturer actually offers the base vector model in 1, 2, or 4 head configuration. But this specific one, the velocity vector 4 marker plotter, utilizes 4 independent print heads working simultaneously. That makes it the fastest configuration in their entire lineup.
Wow.
In fact, the documentation puts it bluntly. It says it, and I quote, prints at speeds of up to 180 square yards per hour, making it one of the fastest plotters available on the market and an ideal solution for meeting aggressive, high-demand production schedules.
Wait, 180 square yards of paper an hour? That fundamentally changes a factory's workflow.
It really does.
It's less like driving a faster car and more like, I don't know, upgrading your factory to a multi-core computer processor. You have 4 separate brains handling parallel tasks to prevent a data traffic jam.
That is a great way to look at it.
But, I mean, moving physical ink at that velocity introduces sheer physics. I'm a bit skeptical of the mechanics here.
How so?
Well, when you put 4 print heads on a single gantry moving at that velocity, the vibration alone usually misaligns the x-axis. So how does the velocity vector 4 marker plotter isolate that kinetic stress?
So the hardware actually leans heavily on its digital integration to anticipate those physical movements. It features native CAD compatibility with industry standards like, Gerber Acumark, Optitex, and Electra.
Okay, so it plugs right into the existing software ecosystem.
Exactly. By processing PLT and HPGL formats through dual LAN and USB connections, the machine effortlessly bridges the digital to physical gap. It isn't just reacting to data, it's buffering the physical choreography in advance.
I understand the software anticipating the movement, but that doesn't solve the friction on the paper itself, does it?
Not entirely, no.
Right, because if you are firing ink across 4 separate heads at those speeds, how do you prevent the ink from smudging or, the paper from shifting under that constant pulling?
Well, they tackle the physical realities on 2 fronts. First, the system utilizes HP45 black ink cartridges, which are engineered for microsecond drying times.
Oh, wow, microsecond.
Yeah, the ink sets almost the instant it hits the medium. That completely eliminates the smudging you'd normally expect at high volume speeds.
So the physical speed of the machine is actually matched by the chemical drying speed of the ink.
Exactly. And second, the documentation highlights an intelligent paper handling system.
What does that mean exactly, like mechanically?
It isn't just a passive roller. It's an active, dynamic tension system. It constantly micro-adjusts the mechanical pull on the paper to keep the surface completely flat and taut.
Ah, so that absorbs the residual vibration from the gantry.
You got it. That's how you maintain sharp, consistent line work without having to throttle the plotting speed.
That is fascinating. So what does this all mean for you listening right now?
Well, whether you are running a high-output garment factory or an integrated textile facility, upgrading your digital workflows is really only half the battle.
Right, because eliminating that final physical printing bottleneck is the true key to unlocking your digital team's full potential.
Absolutely. For years, physical hardware was the anchor dragging down digital innovation.
But now, the hardware is finally engineered to keep pace. Which leaves you with an interesting question to mull over. If physical plotting hardware, like the Velocity Vector 4 marker plotter, has finally caught up to the lightning speed of digital CAD software,
Yeah.
what hidden physical bottleneck in your manufacturing supply chain will technology have to conquer next?